The eye settles on a dim indicator, a pinprick of green on a rack of instruments, and your gaze follows that faint light to a status line on a quiet monitor. Soft fonts, plain words, no fanfare. Across the room, the dome slit is a darker stripe against the night, and beyond it, the sky offers its cold, steady glow. Nothing dramatic happens in this moment. A switch moves somewhere, a schedule awakes, a cue reshuffles, the quiet halo holds. We trace that light outward. One survey passes a coordinate to a clearinghouse, a timestamp, and an uncertainty. Ellipse drift across a screen, then settle. Another telescope nods, not with motion, but with calendar time. The handoff is crisp, like faint beacons along a runway guiding a careful descent. Each lamp simple, each lamp vital. No banners, no breaking news, just the glow of data moving in sequence. Planetary Defense sounds muscular until you see what it is here. Patient measurement and shared clocks. The phrase houses a small, sober practice. First, a detection, then a posting to a public catalogue. Observers reply with follow-ups that tighten a path. A network lives not in sirens, but in harmonized exposures and agreed file formats. It is the light of coordination, not the heat of alarm. Interstellar visitors have crossed our field of view before, and the memory helps us breathe. A fast object in 2017 reminded us the sky still holds surprises. Another in 2019 wore its coma plainly and let us compare the familiar with the far. Both travelled on, and both left their traces as calm lines on plots and quiet papers born of many nights. Those lessons soften the edges of tonight's notice. Sometimes the note that matters most is the one that arrives without adjectives. A minor circular posts at an ordinary hour. The wording is narrow, the numbers are careful, the aims are modest. Refine, compare, confirm. People imagine announcements, practitioners prefer good photometry. It is kinder for sleep and for science to let light do the talking. A single line in a logbook can begin a symphony of small exposures. You can picture the chain as a path of illumination. Islands of longitude take turns under the beam. As one sight brightens with dawn, another grows dark and alive to stars. The baton is luminous, not loud. Before long, a dozen instruments have added their points, and the curve takes shape. In this light, we see why silence can be a form of care. It leaves space for accuracy to form, for unhurried checks that mean we rest on bedrock instead of wish. There is also the gentle truth that comets and small bodies are messy to measure. Their centers of light drift against their centers of mass, and it takes patience to read that glow correctly. Technical notes move faster than press kits because they are meant for people who need the numbers before the adjectives. The room keeps its dim bulbs, the sky keeps its constant lamps, and somewhere between them a position sharpens. If there is a coordinated watch in motion, it is less a secret and more a quiet routine. Astronomers trust the public record that already exists. Posted observations, shared ephemerides, predictable timestamps that mark the night's simple procession. The courage here is to keep the language small while the work stays large, to return again and again to first principles, measure, compare, repeat, until the light maps the path without drama. You might wonder if such hush means approve, slipping thin clouds aside, letting the brighter stars insist on their places, so the faint smear can be pinned more truly. Light becomes the metaphor and the medium, the thing we watch and the thing we use to watch. When a campaign starts like this, the first goal is not story, but certainty. If a kickoff call happens, it is to agree on filters, exposure times, and which reference catalogue will anchor the night. That catalogue is its own lamp in the dark, positions refined by years of labour. Let the new glow be set down with confidence. And in the second half of the night, a long arc appears on the plot where there was only drift before, drawn point by point until the trend is smoother than anyone dared hope. And in that smoothness you can feel the deep relief of being led by light rather than by rumour. Think of how a dim corridor feels when a motion sensor lifts the brightness gently, not to dazzle, but to guide. That is the mood tonight. Instruments respond, people take their stations, but the tone remains hushed, the pace unhurried. Even the way time is marked keeps to illumination. Local midnight, civil dawn, nautical twilight. The vocabulary is a lamp vocabulary, and it keeps anxiety at bay. I will keep my hands on the rail of the readable. A schedule can be real without being shouted. A target can be interesting without being ominous. The sky is unchanged by our words, and the point of this work is to make our words fit the sky. So we let the indicators glow, we let the monitor lines draw their small miracles, and we let one night flow into another until the pattern holds. From that first green point to the last pale pixel at morning, the story is the same. A quiet switch on, a quiet transfer, a quiet correction, a quiet rest. The halo remains, and it is enough. We return to the quiet traveller. The room keeps time. A rubidium clock murmurs in the rack, and every few seconds a relay ticks as a scheduler advances the queue. Another exposure begun, another file sealed. The pulse is gentle, dependable. That is the true voice of Planetary Defense. A steady beat that sorts the night into measured pieces, then threads them together. From the clock's point of view, protection starts as a rhythm. A new moving dot appears on a survey frame. The cadence quickens as software links detections across minutes, then hours. The object is posted to a confirmation page. Telescopes with clear skies pick up the beat and add their notes. Each timestamp is a drumhead, tuned to UTC. Each coordinate lands on the downbeat. What people imagine as alarms is mostly metronome. Discovery flows to reporting. Reporting flows to orbit solving, and orbit solving flows to risk scoring on scales built to be calm rather than dramatic. Torino numbers sit mostly at 0. Palermo values hum below the room's noise. On the rare night a value rises, the beat simply asks for more measures, more data, because the cure for noisy music is not louder music, but cleaner timing. Instruments know their bars. Wide-field surveys sweep first. Eyes like Pan-STARRS, Atlas, Catalina. Follow-up scopes narrow the beam, trading area for precision. When objects are near enough, a radar dish joins with its own bass note, a bright ping that comes home carrying shape, spin, and distance with exquisite timing. The network is a small orchestra of clocks in agreement. The practice is spare. Someone posts to a public page. Someone else slews to the coordinates. A simple astrometric string. A time, a right ascension, a declination, arrives where it needs to land. The Minor Planet Center listens without fuss and publishes without adjectives. Sentry at JPL reads the line, propagates an orbit, and returns a probability cloud. The sound here is statistical whisper, not siren. Protection sounds different because it is built to be largely invisible. Decision trees exist, but most branches invite patience. Observe again, reduce the error ellipse, compare with Gaia-tied stars to shave away systematics. If a threshold is crossed, a notification travels through established channels. If it is not, the tempo returns to its baseline and the object resumes being one more routine traveler. You can hear checks and balances in how the system breathes. A telescope's shutter clicks in a pattern chosen to avoid trailing. Then a cooling fan rises for a moment as an exposure downloads. An operator reads a log out loud to keep the team synced. Filter, exposure time, seeing, sky brightness. The low hum of the dome motors blends with quiet keystrokes as someone confirms the astrometric solution against last night's residuals. Nothing hurries the next tick. Interstellar visitors complicate the melody without changing the virtue of it. Their paths are open curves, their speeds are high, and their comi are untidy for centroid work. Still, the beat applies. Observe, post, refine, because the best way to cradle an unknown object is to set it gently into the same rhythm that has served for 100,000 smaller, nearer stones, and let the timing reveal what drama cannot. When risk communication is needed, even the scale speaks softly. A single digit on a color bar, a sentence fixed by policy, a date for the next update. The language avoids big symbols because percussion can startle a room that wants to sleep. And you're allowed to rest here, because most nights end with the same conclusion. Uncertainty shrank, probability faded, and the pulse continued. This is not to say the music never swells. On the handful of times we have nudged a rock, the crescendo was planned years in advance and built on test notes played over and over until engineers could hum them in their sleep. Even then, the public moment arrived as a downbeat at a specified second, followed by careful measurements of a change period counted in quiet minutes. Cause, effect, verification. The trio always performs. Inside the control room, the leitmotif is the steady pulse. It threads through coffee refills, through recalibrations of plate scale, through the choice to use the same reference catalogue across sites so measurements rhyme. And when weather mutes one instrument, another on a different longitude keeps the measure. Long nights become a single song. If you listen for the human parts, they do not clash with the machinery. A coordinator leaves a voice note that is more lullaby than directive. Chile has clouds, Hawaii can extend 20 minutes. A student checks last month's bias frames and hums to the fan noise while scripts run. Even the elevator's soft chime, carrying someone back from the dome, fits the rhythm. Should a number nudge upward on a risk page, escalation is a tempo change, not a key change. You notify the right people at the right pace. You request radar if range allows. You ask for photometry to estimate size and albedo. You specify when to stop, because stopping is part of the score. Once uncertainty falls below a line, you let the system breathe and return to baseline. Loudness is never the goal. Clarity is. In the second half of a night, when the planet turns most slowly in our bones, the work often resolves into one long patient count, a string of exposures evenly spaced and perfectly dull to anyone who needs fireworks, yet quietly thrilling to anyone who understands that a clean sequence across 3 hours can collapse an error region by half, and move a probability from worth another look to not tonight, which is the sweetest cadence a sleepy scientist can offer. There is room for a small question here. What does safety sound like? It sounds like clocks that agree. It sounds like numbers that converge. It sounds like an email that says, "Residuals acceptable. Please continue as planned." It sounds like the last shutter click before dawn, when the dome hush deepens and the data are enough for today. So we keep time. We treat the unknown as one more bar to play with care. We let the steady pulse guide choices large and small. And the network, spread across continents and oceans, plays its quiet piece without needing applause. Here's the calm tucked inside the numbers. What changes when a third traveller appears on our sky's long road? Less than you might expect, and exactly enough. The route is familiar now, the milestones known, but the next mile marker asks us to check the map twice, then walk a little more carefully. 2 earlier wayfarers taught the habit. The first arrived in 2017, a swift passerby with a path that didn't loop back, a curve that bent outward and away. Its brightness rose and fell with a steady beat, yet its motion carried a tiny extra push, as if the journey had its own breeze. That lesson wasn't a warning. It was a reminder that paths through space can include small forces we didn't account for at first. The second came in 2019, wearing the soft veil of a conventional comet and moving with the kind of speed an interstellar itinerary requires. It shed gas and dust like others we've seen closer to home. Telescopes gathered spectra and images, and the notes fit into the notebook without needing a new section. The road was still the road, and the mile markers held. If a new candidate rises now, the change is simply that our map gains resolution. 2 points make a line. 3 sketch a route. With one more waypoint, we stop treating interstellar visitors as rare caravans and start considering that this lane might be busier than we assumed. That thought is calm rather than alarming. Roads feel safer once we know their traffic. Careful eyes gather because a third stop on the map lets us refine the itinerary. We schedule coverage around approach and closest pass, ask instruments to pace their exposures, and agree on how to write the coordinates so the whole caravan reads the signs the same way. None of that feels like a rush. It feels like settling into a well-practiced walk. The questions we carry are gentle ones. How bright does the coma become as sunlight works on fresh ice? Do the nightly positions line up with the track we calculated, or does the object drift a little off the plotted route? When small offsets appear, are they the road's fault, our atmosphere's seeing and refraction, or the traveller's, with jets or tiny fragments changing its stride? The answers arrive one waypoint at a time. There's reassurance in the sequence. A discovery note lands. Follow-ups reduce the uncertainty of the next mile. If the path is open and the visitor is faint, a long, even cadence of measurements helps most. If it blossoms, we shorten exposures and keep the cadence steady to avoid saturating the log. Either way, the journey metaphor holds. The best way to know where you are is to keep moving and keep checking the signs. You can sense why communication stays measured. On a long trek, calling the destination too early serves no one. We take our time with the map. We compare last night's step with tonight's. We let shared standards do their work so the caravan doesn't split into side paths. The tone is not reticence. It is route discipline. Between the waypoints, there's a quiet stretch where nothing new must be said. The dome nudges along its arc, and the floor keeps its low vibration from the cooling system. Air slips through the slit with a faint, even current. Outside, grass bends in a small, steady sway, and a moth traces its own looping leg of travel beneath the dim red bulbs. Far off, A truck takes a mountain switchback and fades. Inside, a mug leaves a ring on a notepad that already holds 3 neat times, like towns penciled onto a map. No one raises a voice. Chairs turn softly. The click of a distant keyboard is a signpost more than a sound, and time is marked by the rhythm of opening and closing shutters. The room feels like a way station where travellers rest without hurry, the kind with a single lamp over a gentle table and a road that will still be there when we step back out. When the object returns to the chart, we compare. A third interstellar path helps us decide which behaviours belong to long-haul visitors and which were quirks of the first 2 stops. Perhaps the offsets shrink with better calibration. Perhaps they grow when warming increases activity. Either outcome is an answer the road can accept. Both guide the pace of our stride. What if the track stays clean and ordinary? Then the news is that the lane functions as lanes should. What if minor deviations persist? Then we fold them into the itinerary, adding a note that this turn can be slippery. This hill a little steeper than it looks in daylight. Our work does not require a destination more dramatic than understanding. The road itself is the point. Because adding one more waypoint to the interstellar route lets us lay out a more generous, more navigable map, the kind that can be handed from observatory to observatory without more than a line of instruction. There's a quiet joy in how small acts of coordination knit into shared confidence. And confidence is how long journeys avoid unnecessary detours or hurried steps. Across the network, handoffs feel like travellers nodding to one another at trail junctions. A northern site logs the last pre-dawn measurement and tags the time. A southern site picks up the thread after sunset. The caravan moves without any single leader. The road's shape, defined by the physics we keep testing, does the guiding. By the time a third visitor has its arc set down cleanly, the map is nicer to hold. The paper lies flatter. The creases make sense. We mark the mile markers with a softer pencil because the future will supply more. That is a comfort rather than a burden. More travellers mean better maps, and better maps make for safer, calmer nights. So the third traveller is not an alarm, but a companion on the route. It invites us to look up, take a steady measure, and keep walking at a pace that allows both accuracy and rest. The next mile arrives whether we rush or not, and the pleasure here is in the even stride that carries us from one waypoint to the next without stumbling. Let's drift to the next clue. Postcard in time, 0312 UTC. A small office lamp glows over a draft that could become a press note, and the cursor pauses on a single adjective. Someone deletes it, replaces it with a number, and saves. Outside, the hallway is dark. Inside, the work is to choose words that match what the instruments can truly say. The fabric holds. Silence is not a void here. It is unspoken structure. Threads must be strong before they carry weight. In astronomy, that strength comes from repeatable measurements, from agreement across instruments, from analysis that survives fresh light. Until those stitches hold, we leave the loom quiet. The cloth gets better when we don't tug too soon. Communication in space science follows a rhythm that begins far from the press desk. Data arrive in raw frames. They are cleaned, calibrated, and checked against reference stars. Uncertainties are tallied and stitched into tables. Only when the seam between what we think and what we can show is tight do the broader words come out. That restraint is not secrecy, it's tailoring. You've felt the difference in tone. a discovery that is stable and far, an exoplanet many light years away, often comes wrapped in illustrations and quotes, because its thread is already secure. The signal repeats, the transit is clear, the times are precise. By contrast, a nearby fast object with a fuzzy face asks for a different fabric. We keep the weave close and tight, speaking in measured lines so the cloth doesn't stretch out of shape. Technical bulletins are the selvage on this cloth, the edge that keeps the fabric from fraying as more hands touch it. They are plain, specific, time-stamped. They exist so that dozens of teams can pull the same thread without pulling it apart. The public page is there too, visible to anyone who looks, but it isn't dressed with colour until the weave is ready for wear. Quiet also protects the people doing the weaving. It gives room for dissent to breathe and for methods to mature. In a healthy fabric, a thread can be unpicked and replaced without the whole piece unravelling in public. That is not about hidden error. It is about granting the time needed for correction. A claim too early is a snag that never sits right again. There is kindness in the cadence. When an object's path is still being hemmed, we resist the urge to embroider theories. We state what was measured and leave the rest for the next night's frames. If the numbers shift, we adjust the cut. If the numbers hold, we add a line of context. This patience is how the cloth becomes trustworthy, stitch by stitch. Think of the last few years as a lesson in textile care, a strange shape. On one visitor taught us that even a small, persistent tug, non-gravitational drift, can deform a tidy prediction. Another traveller showed that the old patterns still fit, more or less, and that our looms work when the fibres are familiar. With a new candidate, the safe choice is to baste, not bind. Temporary stitches you can move as the pattern becomes clear. The public's place in this is not outside the room. It's alongside the bolt, running a careful hand across the material as it grows. Catalogues remain open, logs update in real time, and plots of position and brightness are shared without drama. What pauses is the story that wraps those numbers in metaphor and mood. We save the trim for after the fitting. You might ask whether this quiet risks breeding speculation. It can, if we mistake pause for concealment. The remedy is simple and unspectacular. Keep the technical channels bright and regular. Post the times, post the residuals, note the outliers. The weave stays visible even when the fashion show waits, and those who care to look can see the garment forming in plain sight. Inside the teams, words are chosen with the same care as exposure times. A sentence that says offsets measured at X arc seconds with Y uncertainty is a straight stitch. A sentence that says mysterious behavior is a loose thread. We favor the straight stitch. Over many nights, straight stitches produce a fabric you can fold, store, and trust later without finding it warped. Sometimes restraint is also about scale. A Planetary Defense label sounds like heavy canvas, but most of the time the job is fine linen, delicate, regular, comfort against the skin of daily life. You don't advertise every seam you reinforce. You do the work, record the measurements, and let the garment do its job. Fit well, wear well, last long. In the second half of the night, when we are most tempted to fill the quiet with words, good practice is to let the numbers speak in their modest register, because nothing steadies a room like hearing that the fit improved by a fraction, that the dispersion narrowed across 3 sites, that a change in reduction cut the scatter in half. And even though such lines will never sell a headline, they are how the cloth becomes strong, how a campaign that began with cautious basting ends, with straight seams, hemmed edges, and a shape that lies flat on the table, inviting anyone to measure it and find it true. We can acknowledge, gently, that different stories call for different garments. Distant worlds invite velvet narratives because the distance itself is a quiet buffer. Near, fast, and faint calls for muslin, transparent enough to see the pattern beneath, sturdy enough to be handled a lot, unpretentious enough to be torn and restitched if needed. Both are honest. Both belong in the wardrobe. So the quiet you notice around a coordinated watch is the sound of hands at the loom. The shuttle slides, the heddles lift, and each pass adds strength. When the pattern emerges and the piece can bear more eyes, we hold it up, not as a surprise reveal, but as a finished, serviceable thing. Until then, fewer words mean fewer snags. We are not withholding a story. We are building one that won't come apart. And when we do speak in brighter colours, the fabric will already be strong enough to wear well in public, to survive questions and rereadings and the pull of new data without distorting. The same soft rhythm carries us forward. Close up first. One faint blur spreads over 4 pixels, not round, but a soft oval, its centre of light a whisper to the left of where gravity says the nucleus should be, a pale centre in the mist. I nudge the cursor to mark it, then let the software fit a profile. Gaussian, Moffat, both asking the same question in different math. Where is the middle of something that isn't quite a dot? Zooming out, the detector is a quiet field of squares, each catching photons in little wells. Stars look like tidy lanterns. Their peaks are sharp. Their wings fall off in clean curves. Comets refuse that neatness. They are mist. The halo bleeds, the tail pulls, and the brightest place may not sit over the heaviest place. That is the heart of the measurement puzzle. A centroid is the balance point of light. For stars, the balance is simple. For comets, the balance drifts with the breeze of sunlight pushing dust and the breath of jets lifting gas from a rotating surface. Tonight's frame shows the drift as a tiny offset, a few tenths of an arc second, almost nothing to the eye, yet everything to the orbit fit. The pale center in the mist moves. Non-sidereal tracking keeps the target from trailing, but it trades one kindness for another challenge. Stars now trail slightly in the opposite direction, turning each reference into a short dash. The reduction pipeline knows this trick and fits along track streaks for the catalogue stars tied to Gaia, so the coordinate grid stays true. Only then can the blurred comet be pinned to the sky with honesty. Filters let us separate parts of the mist. Through a broadband R or R, dust dominates. Through narrowband CN or C2, gas writes brighter. Switch filters and the bright center walks a little, because gas expands differently than dust and can bias where the photocenter falls. We write both down, mark the offset, and learn to let multiple truths live inside the same frame. Atmosphere adds its own thin veil. At low altitude, differential chromatic refraction nudges blue and red rays apart. The comet spectrum is not a star's. Emission lines glow where stellar light stays smooth. Without correction, an atmospheric dispersion compensator or a careful color term in the model, the mist center slides towards the zenith by a tiny systematic amount. One more reason the numbers must be patient. Focus and seeing matter too. A sharp night tightens the halo, the centroid becomes less sensitive to asymmetries. A mushy night spreads everything, letting the tail tug the balance farther from the mass. When the seeing full width at half maximum shrinks by just half an arc second, residuals ease as if someone breathed out slowly across the field, and the pale center in the mist steps closer to where dynamics place it. We do not rely on one exposure. Short sequences build a cadence, 30 seconds, then 30 again, then 60 if the histogram allows. Stack them aligned on the comet to study the coma's shape. Stack them on stars to refine the plate solution. Both stacks tell the truth from different sides. If a jet brightens on one flank, the coma's slope steepens there, and the centroid follows. A soft wonder that can masquerade as physics when it is simply photometry, being honest about light. Trailing losses whisper at the edges. Even with non-sidereal tracking, unmodeled motion inside a long exposure can smear the innermost pixels and bias the fit. Better to bracket, a set of shorter frames to lock the center, a set of longer ones to find faint structure. The orbit solver cares about where, the comet scientist cares about why. Together, they reconcile the map with the mist. There is a quiet discipline in aperture choice. Small apertures privilege the bright core and lessen tail pull. Larger ones embrace more of the halo and drift the photocenter sunward. We report both when the data allow. The difference between them is a clue, not an error. It says the coma is asymmetric, the dust is feeling radiation pressure, and outgassing may be nudging the body in ways the orbit model must acknowledge. Sometimes the mist hides more than bias. It hides multiplicity. If the nucleus sheds a fragment that stays close, two pale centers can merge into one broad core that refuses any perfect fit. Residual maps show a double ridge where one should be. Rebuilding the PSF with two components, we can test whether a second, fainter peak improves the story. When it does, the measured center stops wandering so strangely, and the orbit quiets down. Pixels are honest about their limits. Bias frames, darks, flats, each removes a layer of instrumental fog. Pattern noise, hot columns, interpixel response. The small, steady enemies of precision are tamed with calibration done the same way night after night. Even then, we carry an error bar like a lantern through the mist, not to scare it away, but to see our own feet. The strength of the method is not in pretending clarity when the scene is diffuse. It is in describing the diffusion well enough that two different instruments at two different latitudes agree anyway. When the same offset sign appears in Chile and Hawaii, when the same filter shift recurs under different skies, confidence grows that the pale center in the mist is telling a real story, not a local tale of optics or weather. A long night finds its gentlest work in the second half, when streaks of star trails curve a little more, and the comet's profile, measured 20 times, starts to sing a very quiet theme, because the average of all those centroids weighs small biases down and lifts the enduring piece of signal up, until what began as an oval smudge becomes a position with a pedigree. Time-stamped, catalogue-tied, error-barred, shared, able to stand beside yesterday's position and tomorrow's without wobbling, and in that stability the orbit fit tightens like a slow knot drawn by calm hands. Step back to the wide field again. The comet sits within a scaffold of reference stars whose positions are known to micro-arc seconds compared to our ground-based arc seconds. That mismatch in precision is a gift, because it means the grid is firmer than the mist, and the mist must conform when we do the work. Nature allows us to use the sharp to measure the soft. We never demand perfection from a cloud. We ask instead for coherence across time, filters, and sights. If the photocenter's offset grows with solar phase angle, physics is likely at work. If it vanishes when we swap in a gas bandpass, dust was the culprit. If it flips sign across perihelion, rotation and jet geography are probably involved. These are small comforts, stitched from patient frames, and they let us sleep. When I close the sequence and set the pipeline to reduce while the dome shutters slide, the pale center lingers in mind, like fog lifting from a meadow. Still there, but thinner, understood enough for tonight. The measurement puzzle doesn't demand certainty, it demands care. Tomorrow, another set of frames will add confidence, or show a change, and both outcomes are welcome, because both make the mist a little less mysterious and the map a little more true. We return to the quiet traveller. 3 quiet handrails steady the mind. Earth's night moves west in a dependable rhythm. Sights spaced by oceans and continents meet that wave in turn. A shared cue binds their work into one line of time. With those in place, a global watch becomes less a scramble and more a sea route that our small convoy knows by heart. Think of each observatory as a ship on a blue-black passage. One vessel in Hawaii keeps the object on its bow until dawn rises off the port side, then notes the time in a quiet logbook and lowers sail. Far to the southeast, on a dry Chilean coast, another ship already has the target on its forward deck. South Africa, Australia, the Canaries, each waits in its harbour, lanterns trimmed, ready to take the watch. The convoy passes the logbook without flourish. Handoffs are the art. A schedule marks who stands the next watch, what filters fly, how long each exposure should ride the swell. The entry has the tone of a captain's order, cadence, air mass limits, seeing floor. When the first sight closes its dome, the next raises theirs, checks the same charts, and confirms plot and heading. No speech is needed. The route itself instructs. Lines of longitude are our shipping lanes. A gap in one lane can be covered by a neighbouring one, if weather or power or simple bad luck changes the tide. That redundancy is not just comfort, it is method. 2 ships should sometimes log the same star at nearly the same minute. Redundant positions tell us whether instruments agree, whether currents we cannot see nudge the traveller, whether the logbook entries reconcile to a single track. Parallax adds a quiet trick to the voyage when the target is near enough. 2 decks, far apart, look down different bearings at the same moment, and the tiny angle between those bearings yields a distance like a navigator finding range by the cut of a headland. For the more distant, the effect is small, but the habit of simultaneous notes remains sound seamanship. Communication has its own tide table. Times are written in a single clock, and the coordinates in a single tongue. File names carry dates like hull numbers. The ship in the Pacific writes its figures into the log, pushes them to the common ledger, and the Atlantic ship reads, echoes, and adds. Nothing in that cycle requires a trumpet. It requires punctuality, clarity, and the good grace to keep to the lane. The convoy's deck crew are the instruments themselves. Wide-field scouts sweep like lookouts at the mast. Narrower mirrors act as helms, holding the bow on the target through longer runs. When range permits, a radar call pings the object and listens for the echo. an unmistakable reply that fixes distance and drift like a lighthouse answering across fog. Each roll is named, timed, and bounded by the weather of that sea. Some nights the ocean is glass and steering is easy. Others, a high wind of jet stream seeing makes the deck shiver and the horizon quiver. Commands adjust to the sea state. Shorter exposures, different filters, slightly altered cadence. The point is not to force a perfect line in rough water, but to keep the logbook honest about the route actually taken. If a segment is too rough to write cleanly, the ship heaves to and waits for the swell to pass. A convoy must agree on charts. Star catalogues and distortion maps are the maritime charts of our passage. They fix the reefs and shoals so that each helm can reduce their own compass errors to a known, shared grid. When a chart is updated, a small notice goes through the fleet, and all ships patch to the new edition before the next watch, so no one sails on an old sandbar. What it feels like across the world is uncomplicated and rich. A Pacific dome cools and creaks as the slit opens to a sky so dark the brightest stars look close enough to lift. In the Atacama, a dry wind slides along a ridge at midnight, leaving the mirrors thinly skinned with the night's cold. In the Karoo, a spring insect finds its way to a warm console and rests, wings folded, unbothered by the dim red light. On a mountain island in the Atlantic, the ocean hush is soft and constant, a far surf under the night's own hush. Monitors glow like portholes. Fingers move, few and deliberate. Somewhere, coffee lowers in a cup and is set down without sound. Air handlers murmur. A shutter clicks and clicks again, even and small, then pauses like a breath held. Outside, clouds form low over a distant peak and fail to reach this hill. The convoy glides on. No one rushes the helm, and the logbook gathers its neat lines without complaint. The payoff of such sailing is continuity. A single night's effort might read like 4 clean legs. Hawaii to Chile, Chile to South Africa, South Africa to Australia, Australia to Hawaii again. Even if no leg is perfect, the seam between them is, because overlap stitches them like a well-tied splice, and the track that emerges needs no patchwork story to hold together. When something unusual flickers, a small brightening, a few arc seconds off the predicted heading, the convoy does not yell, "Storm." It sets a small flag in the log and asks the next ship to watch that bearing with extra care. 2 consistent flags merit a course note. 3 transform a hunch into a chart annotation. That is how a fleet learns a current. Tools on deck matter, but discipline carries the day, using the same apertures when the sea state is similar. Reporting the same kinds of numbers in the same units, checking each other's knots. Because nothing preserves a voyage like a quiet logbook kept faithfully from bow to stern, then passed ashore to be copied and read by ships we will never meet, who will set sail on their own nights with our lines under their hands. In the second half of any long run, when bodies feel the scale of the ocean most, a convoy's strength rests in knowing that dawn will catch only one ship at a time, that others are in their comfortable dark, and that a shared log, this modest, durable instrument of trust, will be waiting with the latest entry when the next helm takes its station. Which is why we keep the write-in plain and the headings true, letting the track draw itself from the accumulation of careful watches rather than the heat of any single captain's voice. When the object we follow has made a third of its passage, the convoy can often begin to see the larger curve. The headings required to keep it near the bow change by smaller amounts. The cadence relaxes by a fraction. That is not neglect. It is seamanship, informed by the way the route has revealed itself. And if the sea roughens again, the fleet tightens formation and shortens notes until the water lies down. All of this is quieter than it sounds. No horns, no baying across decks, just a line of ships on a known route, writing in a small hand and trusting that the ocean will permit their pencils to hold steady enough to tell the truth of the night. Here's the calm tucked inside the numbers. Listen first. The night has a tone, a low electrical hush from racks, a faint hiss of air through louvers, a tiny click as a relay changes state. Then, beneath the room, a deeper murmur that is not the wind. Space weather has its own sound if you let instruments translate it. The magnetometer's trace thickens. The GNSS disciplined clock trims itself a hair more often. In the headsets, someone says KP could touch 4, and the words land like soft thunder far offshore. Solar activity turns up the background volume in small, practical ways. Charged particles ride a coronal mass ejection across interplanetary space. When the magnetic field they carry points south against Earth's north, the boundary opens and energy pours into the magnetosphere. We do not hear that directly. We hear it as timing systems that need more careful disciplining, as radio links that flutter, as a sky that grows a quiet glow where it used to be black. The room adjusts by ear. Optical observing feels the change most in the sky itself. Green oxygen at 557.7 nanometers brightens into curtains and patches. Red oxygen near 630.0 nm can lift the background like a distant city's hum. Photometry that once had generous headroom now works closer to the noise floor. Astrometry is more patient than dramatic. You shorten exposures a touch, avoid the narrow bands most affected, and let the cadence smooth the hiss into something you can average away. Timing is a subtler sound. Many domes keep time with a rubidium standard steered by GNSS, the 1 pulse per second tick locked to UTC. During a geomagnetic storm, ionospheric irregularities can make the satellite signals scintillate, complicating position solutions and, if you lean too hard on them, nudging time transfer. Good systems are built for this. The rubidium holds its note on holdover, while the GNSS calms down, and the observatory's clock keeps the beat. The long exposures never needed nanoseconds. They ask for honest seconds that agree everywhere. The network breathes with this weather. A radio dish postpones a high-frequency experiment. An optical telescope rotates to keep a bright auroral arc out of the slit. Someone on shift moves a narrowband filter down the list and nudges a broadband up. None of this is a storm on deck. It is more like a change in room tone. The noise floor rose, so the musicians play a little closer to their microphones and trust the score. If the night runs hot with space weather, the control room listens more closely. Power grids in high latitudes watch transformer currents. Satellite operators track charging risks. We, for our part, care about the simple ability to keep a clean ledger of times and positions. On the wall, the KP bar is a quiet meter, not a panic dial. 5 invites care. 7, if it came, would invite triage. Most nights end below that, and the soundtrack is manageable. There is beauty folded into the complication. A sky bright with aurora hums in colours our work can measure and our bodies can love. The camera sees the oxygen green rise and fall with soft rhythm. Spectra fill with lines that were only ghosts on quieter nights. We do not pretend that this light is helpful to every measurement. We let it be what it is, and root around it where we can. You can think of the Earth itself as an instrument tuned by the sun. The magnetosphere resonates. Currents flow in long loops. The ionosphere ripples and scatters. When the frequency grows strong, the whole system rings, and our devices pick up the vibration. A slightly noisier GNSS solution here, a brighter sky there, a magnetometer with a thicker pen stroke across its scroll. None of these require raised voices. They require engineers who built in margin and observers who listen. A small practice helps. Before a run, teams check the 3-day outlook, the real-time solar wind charts, the aurora dashboards. If a warning says active to minor storm conditions, you write a quiet note into the plan. Avoid the most aurora-sensitive filters, carry backup timing references, confirm clock offsets before and after long sequences. If the warning lifts, you restore the quieter settings. The work is a gain knob, not a switch. In all this, the traveller we follow remains the same. Its photons arrive when they arrive. The slight acceleration we care to measure, the centroid we want to pin, those are still present under the added hum. So we pace ourselves. We accept a little more scatter and use a little more averaging. We lean on cross-site agreement more than usual, because independent instruments separated by oceans rarely share the same local artifacts, and if both report the same small shift on a noisy night, that note is probably true. Space weather also has a human tempo. On active nights, people sleep nearer to their phones. Slack channels see a few more eyes-on messages. A coordinator may drop a mid-run reminder to re-verify timestamps against the facility clock after the last exposure. None of this is breathless. It is simply what a careful band does when the room gets louder. Watch cues more closely, keep the tempo, trust the chart. The second half of a storm-touched night often surprises with how normal it feels. Because once the adjustments settle, the altered exposure ladder, the confirmed time base, the swapped filter order, what remains is the same soft work as always, a sequence of even frames that, taken together, suppress the wandering hiss and let the signal glide out, until the final stack looks less like a struggle against noise, and more like a recording made in a slightly livelier hall, one that the engineer then masters into a clean, quiet track with transparent hands, so that when you listen in the morning, you can still hear the comet's small melody without straining for it at all. When dawn approaches, the hum drops with it. Aurora fades first to grey, then to memory. The magnetometer's trace thins. The GNSS solution steadies into its usual crispness. You hear the room again, the fans, the louvers, the relay, the click. Logs close with ordinary times. Data pipelines push without retries. The sound returns to baseline, and the night's work sits there on disk with the same modest dignity the quiet nights have, which is the whole point of designing systems that don't mind a little weather in the wires. We measure the sky by listening for steadiness. Space weather reminds us to keep the metronome nearby, and the gain within reach. With that discipline, even a noisy night can produce gentle, useful notes, and the music of a small body moving cleanly through our field can still be heard above the solar chorus that sometimes swells around it. Let's drift to the next clue. If a comet glows a little brighter than the simple curve suggests, then the safest reading is small physics at work, not large mystery. Light answering sunlight in familiar ways. If a measured position sits a hair off the prediction, then the first suspect is not gravity failing, but light drifting from the true center as the coma breathes. If then, softened by patience, tends to be enough. Light is our language here. Dust scatters it, gas emits it, and both can bias where the brightest patch falls. A jet flickers from one face of a rotating nucleus and the glow leans. Hours later, the nucleus turns, the jet points elsewhere, and the glow leans back. Average the night and the offset shrinks. Examine minute by minute and the offset seems to wander. The quiet offset is a symptom of light's habits rather than a signal of something unsaid. Outgassing is the gentle engine. Ices sublimate. Water nearer the sun, carbon dioxide and carbon monoxide farther out. And the escaping gas carries momentum that nudges the nucleus. Orbit models expect this. They include small, sunward, and along-track terms, so the fit can absorb a slow, rocket-like push. Those parameters are everyday tools, not exotic patches. They exist because light makes vapor, and vapor makes motion. Fragmentation is the other ordinary source of oddness. A pebble or a boulder lifts away, stays close for a time, and the two together masquerade as one lopsided core. The photocenter shifts toward the brighter piece. The orbit solution complains. And the simplest fix is not a new law, but a new component in the fit. Nights later, the pieces separate enough to resolve, and the fuss dissolves into two calm points in the ledger. Light also carries color, and color mischief matters. A broadband frame weights dust, a gas band brightens molecules, and the center can step between them by a fraction when filters change. That step is not a warning bell. It is a label on the glow, telling us which part of the light we measured most. When we keep track of that label, small discrepancies stop feeling like secrets and start behaving like notes on a score. The same comfort applies to timing. A comet's light curve rises and falls with distance, but rotation modulates it, and nights of steady cadence capture that pulse. If brightness surges for an hour after a long quiet, then calms, we mark an outburst rather than an omen. If the surge repeats with the nucleus's spin, we have found a jet's latitude indirectly, using only light and rhythm. We have watched these patterns before. A mission rode beside a small, dark world and filmed jets carving sunlit plumes from cliffs, then measured how those plumes changed the rotation by minutes over months. A shattered string of fragments once struck a giant planet after tides pulled a single body apart. Telescopes saw the chain well in advance. A comet nearer home split into dozens of pieces and paraded past in 2006. The catalogue lists their paths as calmly as it lists stars. Anomalies, when real, tend to be small forces and many shards patiently tallied. So we treat brightness and position as entwined. Photometry informs astrometry. If the light leans in the sunward direction, we check for a tail that's pulling the centroid. If the motion deviates along track, we check whether increasing activity toward perihelion could supply the push the model needs. We add the usual non-gravitational terms, refit, and see scatterfall. When it does, the anomaly becomes a parameter with a name. Even the language is designed to be calm. We talk about outgassing forces, but they are small, felt over weeks, expressed in thousandths against gravity's whole. We talk about breakup, but most such events are drifts, not detonations. The light spreads, the nucleus loses coherence, and the story reads as a slow fade rather than a sudden flare. The quiet offset remains a leitmotif, and light keeps explaining itself. If a visitor came from between stars, none of this stops working. Interstellar ice still meets sunlight. A rotating nucleus still carries patches that wake early and sleep late. Dust still skews brightness away from mass. The numbers may differ, a richer CO supply here, a lower dust-to-gas ratio there, but the vocabulary holds. We do not need a new alphabet for old light doing its ordinary work on a new traveller. There is room for humility. One earlier interstellar guest did accelerate without an obvious coma. We wrote that down and argued carefully about causes. Another looked textbook normal and then hinted at fragility near the end of its passage. Both episodes taught restraint. Begin with the humble mechanisms, fit them hard, and only then ask if something remains that light and vapor cannot cover. Most of the time, they can. Notice, too, how cross-checking tames drama. 2 sights, 2 filters, a shared clock. If all agree on a small sunward bias growing toward perihelion, we favor jets over tails beyond physics. If a sudden brightening appears only in one instrument, we suspect weather, moonlight, or calibration before we name a fragment. The rule is not cynicism, but sequence. The ordinary first, the unusual only if the ordinary cannot stand. In the long run of a campaign, the second half often brings the kindest evidence, because patterns reveal themselves only after we have enough light to see them repeat. And repeating light is the gentlest kind of proof, the kind that replaces anxious why with the soft relief of there it is again, turning a restless cluster of points into a curve with a character we can name and predict, and then test again with tomorrow's frames until even the small deviations look like the natural flutter of a living, evaporating rock rather than the signature of a grander unknown. If then remains our friend. If offsets shrink when we tighten focus and air mass, then seeing was the culprit. If offsets grow with activity while along-track deviations increase, then ordinary outgassing is likely at play. If breaking light resolves into 2 points, then the orbit model wants 2 bodies. Each conditional is a stitch. Enough stitches make a fabric that holds weight without tearing, and once it holds, we can rest on it. The quiet offset keeps us company. It reminds us that light is both messenger and mask, and that reading it well is an act of calm rather than a chase. The same soft rhythm carries us forward. A thin red line leads the eye. Not warning red, but the muted H-alpha glow on a status bar and the safe hallway lamps that keep their promise through the night. Steady, low, kind to pupils. I let that red guide the tour of new tools made for old light. Start with the backbone. Star positions are now so precise that a single field looks pinned to the sky by invisible tags. When we solve an image, the world coordinate grid clicks into place with a satisfaction you can feel in your shoulders. The comet's soft center rides inside that certainty. Red pixels on a residual plot thin. Offsets shrink. The line holds. Precision grows in the small decisions. A model of the point spread function, how a star's light spreads over pixels, learns the shape of the night in each frame. It updates quietly when the focus drifts by. A breath, or the air, grows a little wilder. Deblenders separate nudging neighbors. Solvers match patterns against wide catalogues without fuss. Every step is mundane and modern at once, and the effect is that positions land where they should with less argument. Then the newer helpers arrive, wrapped in code that looks unromantic until you see what it does to noise. A classifier trained on years of images stops hot pixels from masquerading as starlight. A regressor learns the tiny color-dependent wiggles that air introduces and subtracts them before they harden into bias. A difference imaging pair cancels the static sky, so the moving faint smear stands up straighter against the dark. The red progress bar inches, then completes. The plot tightens. None of this changes the photons. It changes how gently we hold them. The old reduction ladder still stands. Bias, dark, flat, solve, measure, fit. But each rung now has a firmer bite. The comet's photocenter in broadband gets a companion measurement in a gas band, and a learned correction maps one onto the other without smearing away meaning. We keep two colors honest, then let the orbit fit choose. Ambience gathers in the quiet between steps. Red LEDs keep a dome safe for dark vision. A small heater ticks in the console bay. On the monitor, a faint smear brightens by a line of counts, then eases back while the histogram reshapes like a slow tide. Outside, frost paints a low railing, and the dish of the dome breathes as metal contracts, a soft ping spaced by long silences. Red light pools on the floor near a coiled cable. The night smells briefly of dust and cold aluminum when the door opens, then nothing again. A moth pauses on the edge of a screen where the warmth is kindest. In the far distance, a snowcat grumbles and fades. No one speaks. The red line on the process meter becomes a full bar, and a tiny chime, barely there, approves the frame. What the tools buy us is composure. When the sky grows restless, the model absorbs more variance without passing it along as false motion. When the coma leans on one side, a robust centroid stays centered because it weights the inner pixels with care learned from thousands of similar nights. When filters change, a color term, tuned by stars of known hue, keeps coordinates from drifting by fractions that used to cost us confidence. Scheduling has taken the same lesson. A planner examines weather predictions and past seeing at each site, along with a target's ephemeris, and suggests a cadence that equalizes precision across the chain. The handoff improves because the red block of time at one site meets the next block, where their air mass and seeing truly overlap. We spend fewer minutes fighting windmills and more watching the object when the air is kind. Red appears again in the alert stream. A line goes from grey to crimson only when a threshold is met. Residuals outside the band at two sites, a brightness step that repeats after rotation, a time-based discrepancy larger than policy allows. The colour is a nudge, not a siren. It asks for a second look and offers the likely place to find the issue. Most of the time, the second look restores grey. Behind the scenes, training happens in the slow hours. Simulated comets with known offsets are rendered into fake skies, then reduced as if they were real. The system learns what error smells like and what true motion tastes like, so that on live data, it does not jump at shadows. Stars of many colors help teach the air's quirks. Fields with known distortions teach humility. The red curve on a validation plot dips as bias falls, and we trust that curve only after it holds for weeks. None of this replaces a person choosing to mask a bad corner, or to refocus when the temperature drops faster than planned. It simply offers better footing, so those choices are rarer and clearer when needed. The comet benefits from the same virtue any traveller does, a well-lit path. Here, the lighting is mathematical, and the glow is the quiet red of good interface design that stays out of the way while you work. In the second half, night. When fatigue leans in, these tools protect the judgment that precision requires, because models catch the dull mistakes we make and nudge us gently back to center, while leaving the interesting deviations untouched. And that is the delicate line we have always wanted. Automation that lowers noise without sanding off the signal, leaving a clean track where each point has earned its place. And the fit becomes a calm ribbon that even a cautious mind can trust after sleep. There's a deeper grace here. Better calibration means fewer arguments about whether an offset is a comet's doing or a camera's. It means a wider community can join without all the tacit craft a veteran carries, because the software now carries some of that craft openly and repeatably. It means the light we collect can be compared weeks later by people we will never meet and still agree. The red thread through all of this is simple. Make the measurements kinder to the truth. We end where we began, with a red line that is not a warning but a guide. It tells us a process has finished, a frame is clean, a position has settled, a cue is aligned. It lets tired eyes relax and trust that the next decision can be small. We let the color lead us not to drama, but to discipline, and the comet's faint path thanks us by being easier to read. We return to the quiet traveler, gentle Q&A to open. What did the first interstellar visitor teach us? That a path can be open-ended and still obey the basics. What did the second teach? That familiar chemistry can ride a faster wind. Two answers, softly spoken, and their light still helps us read tonight's sky. Question 1. Why did the 2017 traveler feel different? Because it brightened modestly, faded as expected, and then left a small, persistent residue in the numbers, a push not fully captured by gravity. We traced it in the residuals, the tiny along-track drift that stayed after careful fits. The answer was not an alarm. It was an invitation to widen the model by a sliver, to let sunlight and surface physics contribute a little more to motion than our first draft allowed. Light showed where to look. Question 2. How did the 2019 guest temper that surprise? By arriving wrapped in a classic coma and tail. It bled gas and dust in the old way, wrote clear emission lines in spectra, and moved through the inner system with a speed that felt brisk but not unruly. This was the comfort of recognition. Carbon monoxide bright, cyanogen and other friends present, the whole glow behaving as if it had been trained in our own Oort cloud schools. Light spoke a dialect we knew. Next question. What do these two together say about a third? That we should approach with steady hands. The first urges caution in assuming mass alone sets the course. The second reminds us that nature repeats when it can. Put together, they suggest a calm middle. Begin with the ordinary comet playbook, then leave room in the margin for a small extra term if the light insists. Light sets the margin's width. Why did the first visitor spark such wide curiosity? Because it looked unlike typical small bodies. Its brightness varied as it tumbled, implying an elongated or flattened shape. Its trajectory was open. Its post-fit drift asked for a gentle nudge beyond gravity. We could not see a coma. Light, that old messenger, withheld the usual veil. With that absence, 1,000 papers took their measures, and the better ones kept their verbs small. The answer remains careful. Modest, non-gravitational acceleration, no resolved dust, several plausible ices or surface effects could do it. Why did the second quiet that storm? Because the coma announced itself in the earliest images. Observers across the world gathered spectra and saw gas and dust behave with reassuring consistency. Follow-ups showed a conventional brightening curve toward perihelion, then a fade with hints of friability near the end. It was not boring. It was grounding. Light returned to its customary grammar, and we listened gratefully. What do we keep from those campaigns that matters now? The craft, mostly. Early, frequent astrometry with shared star catalogues. Multi-filter photometry to keep dust and gas stories separate. A cadence long enough to catch rotation and short enough to catch outbursts. A patience that lets several nights cover the same phase angle before naming a trend. Light prefers to be averaged when it is fidgety. Is there room for wonder without drama? Yes, and it lives in precision. The first visitor's tiny drift became meaningful because the measurements were clean. The second's normality meant something because the comparison was fair. The comfort here is that truth does not require large effects. It requires quiet agreement. Light, measured well, is calm even when the subject isn't. Do these precedents narrow what we expect from a new traveller? They narrow method, not mystery. We expect to test for small pushes as activity grows. We expect to check for colour-dependent centroids when filters change. We expect spectra to reveal whether the coma is dust-rich or volatile lead. And we expect, above all, to keep the adjectives behind the numbers until those numbers settle. Light comes first. Gloss comes later. What about communication? Did the earlier stories show a rhythm we can borrow? They did. Technical notes led, then broader summaries flowed when the curves were stable. Press images arrived when follow-up had stitched a coherent cloth. The world learned enough to feel part of the voyage, but not so much so soon that the weave distorted. Light dictated cadence. Language followed. And what of risk? Did either suggest anything alarming about interstellar passers-by? Neither did. Open orbits carry travellers on their way. Even with a small acceleration, the first visitor did not turn toward us. Even with fragility, the second did not linger. The practical lesson is simple. Watch closely, model modest forces, and rest in the knowledge that passing through is what such objects do. Light gives us time. Where do these answers leave us tonight? With a toolkit that fits in the hand and a temperament that chooses the middle path. We begin with gravity. Add sun-driven terms if the residuals ask. Look for dust. Listen for gas, and let multi-night patterns rather than single frames guide our claims. If a third traveller sings a familiar melody, we will hum it quietly. If it changes key a little near the chorus, we will add the harmony it deserves and nothing more. Light will pick the note. Under that posture, even a surprise is absorbable, because we have already agreed with ourselves to approach small bodies as living, changing surfaces pushed by photons and heat as much as pulled by the sun, and that agreement keeps any new curve from feeling like a rupture, which is one reason sleep is possible during campaigns like this. The unknown is fenced by ways we already know how to walk, and those fences are built from care, routine, and shared experience, rather than speculation. Most of all, the two precedents teach that curiosity and composure can coexist. It is possible to be utterly interested without being unsettled, to be meticulous without making noise, to offer the public a steady view that doesn't trade accuracy for applause. That combination, eyes wide, voice low, is the stance that serves a listener in bed and a comet on the screen equally well. letting both settle into a slower breath as the data accumulate and the next small answer comes into focus. Because in a room like this, light isn't just what we collect. It's how we behave around what we've collected. And that is the lasting lesson from the first two visitors as we greet the third. Here's the calm, tucked inside the numbers. Dear listener, this part is for your breath. Slow in, slow out. We'll talk about unlikely things, the way an engineer tunes a volume knob. Quietly, with numbers near hand, and with a finger ready to turn the sound back down. When people say risk, rooms often grow loud. Here, the room stays soft. We start with scales that whisper more than they shout. One scale runs from 0 to 10, but most nights sit at 0, the needle hardly moving. Another uses negative numbers that mean quieter than background. And that is where almost all candidates live once a few clean measurements arrive. You can think of these scales as a pair of studio monitors. One tells you if anything suddenly spikes. The other tells you how far below the room tone you are. If a number twitches upward, the protocol isn't to play a siren. It is to lower the noise. Add observations at the right times. Ask a radar to send a bright ping if the range allows, and listen for the echo. In music terms, we isolate the track. Pull every other fader down. Let the true signal, if there is one, step forward without competition from hiss and hum. Small probabilities deserve small voices. 1 in 10,000 sounds like a headline until you notice the part that reads 10,000. That is a field of quiet with one faint bird call at its edge. We handle such odds with posture, not panic. Plan how to cut the uncertainty in half, then in half again, and stop when the volume drops back under the noise floor. History gives examples that soothe more than they stir. Once, a small rock was spotted with less than a day's notice. Predictions said it would end high in the atmosphere, and it did. Instruments heard the boom, and fragments fell harmlessly in a desert. Another time, a morning sky flashed over a city, and glass rattled in its frames. People were startled. Many were cut. But the lesson was clear and practical. Windows are fragile, and warnings help most when they say simple things. Step back, look away, let the wave pass. There are drills for this work. If a path brushes an uncertainty cone across a date many years ahead, the plan is to watch it at the next favourable season, send timing and position to the shared ledger, and let each new data point lower the sound. Years can be friends in this music. Time dulls the hiss. You may wonder where thresholds sit. What number makes a quiet room turn its head? They're less dramatic than rumour would have it. A modest probability at a specific time, combined with an object of significant size, buys more telescope time and perhaps a radar track, not a press conference. If a number crosses a higher line, notices go to the right desks. The language stays measured. The plan stays layered. Even then, much of the response sounds like careful desk-side conversation rather than a public address system. Communication matters because fear is loud. The way to keep the mix clean is to lead with measured signal. When an object's odds shrink, say so. When a new observation is scheduled, say when. When a threshold for escalation exists, say what it is in plain terms. Most of the time the postlude reads the same. Probability down, path clarified, program complete, and the volume returns to its baseline without anyone's pulse needing to climb. The beauty of this approach is that it treats small bodies like music we already know how to record. We set our microphones far enough from the drum that they don't clip when the stick strikes. We hang a blanket when the hall rings too long. We check the metronome against the drummer's foot. Translation. Exposure times won't saturate if something flares. Background variations, moonlight, aurora get accounted. Clocks at separate sites agree to the second. When you do these basics, improbable notes don't masquerade as crescendos. Consider the role of radar again as a kind of subwoofer test. Optical measurements place a moving dot on the sky with exquisite angular precision, yet distance along the line of sight is where uncertainty hides. A radar echo collapses that axis. One pass can calm a model that would otherwise take weeks of optical work to settle, because a single bright return locks range and range rate like a tight kick drum anchoring a mix. There's also the matter of where our attention goes when numbers turn out to be small, which is almost always. It goes back to the quiet core of the project, learning and routine. People who watch the sky sleep better when they practice edges in daylight. Tabletop exercises trace a scenario from first detection through to nothing to see here, and we'd like a bit more data, please, because knowing the script keeps emotion from adding distortion to the channel. It helps to remember that even when a small chance stays small for a while, the strategies in play are forgiving. Orbits are not fragile things that suddenly jump. They are curves with widths that narrow steadily when fed good time-stamped positions, and the mathematics here is on our side. Every additional night that lines up with prediction halves the doubt, and every clever geometry, an opposition when the target is closest, a radar window just right, halves it again, until the quiet overwhelms the speculative by simple accumulation. In the second half of any discussion like this, I like to say aloud what the body already knows. The mind rests when the room is tuned, and this room is tuned on purpose, with thresholds that avoid false alarms, with instruments that hold time even when the radio crackles, with a habit of writing down what is decided and why, so that later, when someone asks whether we were careful with a small odds number that briefly felt large, we can point to the score and show the bars where the beat never faltered. And that confidence, a human, unglamorous, repeatable confidence born of many nights and small corrections, is the real sound of safety. When plans do tilt toward action, rarely and with long-led times, the notes are still quiet. They say who watches next, what measurement matters, and when the piece is considered played to its end. If instruments learn something new, scales move back down. If instruments learn something unexpected, the next steps are already in the binder. The mix stays balanced. So, if the object we're following tonight whispers anything outside the predicted line, the microphones are in place, the levels are set, and the people at the board know how to lower the hiss without muting the song. Your breath can match that steadiness. In through the nose, out through the mouth. Listen for the room tone. That's us, together, keeping it low. We return to the quiet traveller. Night shift, low lights. A kettle steams near the sink, and the lab bench is a tidy rectangle of purpose. Lint-free cloth, lens blower, notebook open to a grid of neat times. The sort of desk where questions get placed on trays and answered in order. Past midnight, decisions feel like pipetting. Slow, level. Nothing spilled. This is where steady watching earns its keep. The pile of frames is no longer a heap. It's a rack of labelled tubes. Each exposure has been decanted into numbers, each number capped with an uncertainty, each uncertainty shelved beside its neighbours, so cross-checks can find them without rummaging. A campaign becomes a bench protocol. Heat samples gently. Swirl, don't shake. Note the time, initial the page. What does the bench teach before the debrief? That patience has a texture. Early steps were rough measurements and provisional fits. Mid-run brought deliberate changes to exposure ladders and filters. Late nights shifted toward repetition on purpose. Repetition isn't the enemy of discovery here. It's the incubator you set to a quiet 40 degrees, so the signal can grow while the noise starves. It takes trust to leave the lid closed. Small truths gather first. A filter change moves the photocenter by a fraction. Write that down in ink. A shift in seeing widens the halo and the fit, then narrows again as the air calms. Draw a line through it with the same pen. A cadence catches a gentle periodicity you didn't try to force. Add a margin note, not a headline. The bench loves modesty because modesty stacks without collapsing. Questions that remain open don't feel like failures under these lights. They feel like labeled samples doing their quiet work overnight. Did the along-track residuals keep the same sign across sites? The columns accept a new checkmark when the plot says yes. Did the gas band centroid trail the dust band by the same distance all week? Another mark goes in a tidy box. Will the offset grow as the phase angle steepens next week? The cell is penciled, not inked. The lab knows the difference. A debrief will ask for 3 sorts of things. What's certain, what's strong, but still soft, and what needs another run. Certainty sounds like positions tied to the same catalogue at these times, with these dispersions. Strong but soft sounds like offsets with consistent sign in these filters, larger near this date. Another run sounds like brightness steps that appear in one site only, pending confirmation. Nothing in that list needs a drum. Everything needs a bench. Ambience settles in for a minute, the kind that makes the back soften. The kettle clicks off and blooms a small cloud that vanishes before it reaches the cool fluorescent tubes. Down the hall, a refrigerator compressor hums, pauses, and hums again. The cadence is friendly. A pencil rolls an inch, then stops against the notebook spiral without falling. Air from the ceiling diffuser strokes a printout until one corner lifts and settles. Lifts and settles, as steady as breath. Rubber soles whisper over linoleum, and a door latch gives a rounded click, not a sharp one, as someone steps out to the balcony for 3 slow lungfuls of cold. A box of Kim wipes crinkles when it's moved, then quiets like a small animal sleeping. The building itself creaks once, clean wood, dry and light. Then nothing. The kettle is forgotten. The bench keeps its promise. By now, the notebook's grid looks less like a to-do list and more like a method. 3 columns, time, filter, residual, have become a way of thinking that will be easy to carry into the meeting. If a plot disagrees with a paragraph, the plot wins. If a paragraph must exist, it will be written last and contain what the bench can stand behind when read in daylight. The lab's ethic is portable. There's a kindness in closing loops before the call. Verify the clock offsets one more time. Rerun last night's frames with the same PSF model used at the partner site to ensure apples have been apples all along. Check that the gas band images weren't quietly contaminated by a rogue glow near the edge. Mask it if so, and note the mask. Kindness in a lab is just precision done, while people are a little tired and a little proud of their restraint. We don't force closure, we stage it. If a hypothesis about a jet's geometry has legs, it will be granted a test, rather than a declaration. A specific phase angle to re-observe, a night-side rotation window to target, a shared choice of aperture to replicate the centroid behavior. If a whisper of fragmentation lingers in a residual map, the bench writes down a candidate separation rate and the expected date, when two peaks would finally pull apart far enough to be seen with the seeing we tend to have. Plans, not pronouncements. In the second half of the shift, the whole space feels calibrated toward that posture. Speak in values with units. Prefer plots to adjectives. Let the convergence rate be your mood. Because a long night of small agreements becomes a kind of lab glass. You can hold up to the light, clear enough to see through, strong enough to clink without breaking. And when the call arrives tomorrow with its efficient agenda and its request for one slide per site, the beaker won't wobble in your hand. You'll pour out enough for everyone, and nothing will spill, which is exactly how you sleep after a campaign, even when a few vials remain in the incubator with their labels turned outward, politely waiting for morning. What steady watching teaches, before any debrief, is that an open question can be restful if its container is sound. Tonight's containers are good. The residuals lie inside predictable bands. The steps we took are reproducible at other benches, and the parts we haven't named yet are small enough to leave in the rack without anxiety. The lab closes itself softly, switches to standby, caps tightened, notebook dated, and you leave, knowing the samples will be there tomorrow, clearer for the waiting. When dawn slips its first pale rectangle across the floor, it doesn't wash the chalk off the board, it dries the ink. The bench remains what it was all night, a place where light is portioned, labelled, and allowed to settle until its story pours cleanly into a common cup. The same soft rhythm carries us forward. We've walked a quiet circuit together, facts first, voices low. 2 interstellar visitors set the baseline, one in October 2017 with a small extra push beyond gravity, one in August 2019 with a classic coma and tail. Catalogues and circulars carried their positions in UTC, nights after night. That part is settled. The networks that keep nights orderly remain in place. Surveys hand discoveries to the minor planet center. Follow-ups refine in shared formats. JPL's risk pages update as new measurements arrive, and most entries live at the calm end of the scales. When radar is in range, a single pass fixes distance, and drift, with a precision optical work, cannot touch. Those are tools we can trust. On the measurement side, the scaffolding is firm. Gaia's star grid anchors ground images. Point spread models and D-blenders keep crowding honest. Narrowband gas and broadband dust filters tell different parts of the same light. Differential refraction and seeing are measured and corrected instead of wished away. Cross-site agreement is the gold standard, and it is achievable. Space weather can color a sky, yet instruments and timing hold. Auroral lines lift the background. GNSS disciplined clocks ride through on holdover if signals flutter. On those nights, cadence and averaging recover the steady center. That's experience, not theory. Across longitudes, the handoff works. Hawaii, Chile, South Africa, Australia, the Canaries. Lanes pass the watch, so a faint traveller stays inside a shared page. Overlap confirms, and gaps are expected, rather than feared. Before any debrief, benches do what benches do. Frames are reduced with common models, clocks are verified, and open questions are labelled rather than declared. When a residual repeats across sites, it earns a test plan. When it doesn't, it becomes a note for the margin. That is the whole comfort. Observed light, measured cleanly, makes small answers accumulate. Thank you for breathing with this pace, for letting numbers do their quiet work. May your room be as tuned as a good control room, your rest as even as a long cadence, and your night as kind as a sky that keeps its promises. Good night.